This is the solution video for question 9 from paper 2 of the 2019 TMUA or CTMUA exam. In this question we're told a circular table has 40 chairs and we're told to find the smallest number of people who can be sitting at this table already so that the next person who comes to the table must sit next to someone. And we're given 6 possible answers ranging from 9 people already sat at the table all the way up to 20 people already sat at the table. So firstly, let's draw a diagram to get a better idea what's going on. So here's our circular table and we'll draw seat possibilities at the head of the table. So we've got seat 1 up here, then we number them clockwise all the way around to 38, 39, 40 and then we restart because we've got 40 chairs in total. So the first thing we're going to do is find a lower bound of what our optimum number could be. What's the best we could dream of doing? So the way to reason this is, think about if someone sat somewhere, say at 2. What does that mean? Well, that means if someone's coming to the table and doesn't want to sit next to someone, they can't sit at 1, they certainly can't sit at 2 because somebody's already sat there, and they can't sit at 3. And similarly, if someone sat at 38, it means no one can sit at 37, 38 or 39. So that means for every person sat at the table, they eliminate 3 seats that people can sit at. So, because there's 40 seats in total, if we do 40 over 3, we get 13 and a third. So this implies that if we've got 13 people sitting down around the table, there's always going to be at least 1 seat free. So we know that 14 is the best answer we can dream of for this. So if we can come up with an arrangement of seating such that 14 people are sat at a table and someone new can't find a seat to sit in, we know our answer is 14. So let's try and come up with an optimal arrangement. So let's sit the first person in our scenario at seat 1, because it doesn't matter where we sit them, because we can just rotate the table around and change our numberings. So let's go for the first person at seat 1. And let's go clockwise. So it makes most sense to sit someone at seat 4. Why is that? Well, seat 2, it feels a bit of a waste, and so does seat 3 because seat 2, no one can sit there because they've got 2 people next to them. So seat 4 makes sense because it means no one can sit at 2 free, but if we extend it any further, we miss a seat that someone could sit at. So seat someone at seat 4. And using the same logic, we'll get someone at seat 7, 10, 13, etc. all the way around to 37, and that will be 13 seats up to here. And we know if we can build a solution with 14 people sat down, such that someone coming new to the table doesn't have anywhere to sit without a neighbour, we're done. And we can see the only possible seat that we need to stop someone sitting at is 39. And the easiest way to do that is just sit someone there. So we've built a solution with 14 people, and we know our lower bound for our answer is 14, and so we know our answer must be 14, which corresponds with D in our options, and so our answer is D.